Welcome to Part 2, as we turn our attention to an important subject, that of fastener threads. In simple terms, a thread is a spiral groove that is cut or milled onto a piece of round stock material such as steel round bar. When the groove is cut into a rod, it is known as an external thread. When it is cut into a pre-drilled hole, it is called an internal thread. The external thread is cut to the same form or shape as an internal thread so that they will mate or match each other. In this cutaway view, you can clearly see how the external and internal threads have engaged and how the threads travel along each other. Most threads are made in such a way that by turning a fastener in a right-hand direction, there is a tightening effect. We call this a right-hand thread. Let's now learn some basic thread terminology. Fastener threads, in close-up, look something like a series of V-shaped hills and valleys. The hills we call crests, and the valleys we call roots. The distance between one crest and the next on any one fastener is the same. We call the distance between crests the thread pitch, or just pitch. The size of a given fastener will usually determine the pitch dimension. As already mentioned, the size of a fastener is the specified diameter across the threaded section. In practice, this diameter, if actually measured, will usually be a little less than the specified diameter. For example, a bolt specified as 10 millimeters in size will actually measure around 9,7 millimeters. This is usually because the crests, during manufacture, are slightly worn by the thread cutting tools. We would like to introduce you now to a very useful little instrument known as a pitch gauge, also known as a thread gauge. The instrument comprises several gauge blades, each blade representing and conforming exactly to a specific thread form and pitch. Marked on each blade is the pitch in millimeters, on the example shown. The pitch gauge that we're going to use contains metric gauges in the side marked SI 60 degrees and Whitworth gauges on the opposite side. At this time, we will only concern ourselves with the metric gauges. By way of demonstration, we shall randomly select a fastener from this pile and, using our two instruments, namely a vernier caliper and the pitch gauge, we will attempt to identify it by size and thread. By measuring across the threads, we see that it is slightly under 8 millimeters, and by the head marks, we know it is metric. We now open up our SI pitch gauge and select a gauge blade that most closely resembles the thread. Let's try this gauge, marked 1,5 on the threads. No, it doesn't want to enter the threads. So let's try this 1,25 gauge. And as you see, it's a perfect match. We can now identify our fastener as being metric, 8 millimeters in size, and having a pitch of 1,25 millimeters. Let's work through another example, again with a metric thread. Measuring tells us that we have a 12 millimeter sized cap screw, and by using our pitch gauge, we see that the pitch is 1,75 millimeters. We can now specify its standard size and pitch as metric, 12 millimeters with 1,75 millimeter pitch. A more complete description could be given by including the length and type of fastener. We only measure the length of the shank, which is in our example 40 millimeters. The almost complete description of the fastener can now be written thus: M12 1,75 mm pitch, 40 mm long cap screw. After the break, we shall compare metric and non-metric fasteners.